Hey guys, so my voice is somewhat back, so I'm going to attempt to record these last two videos for you guys. Um, all right, so for 12.3, we are going to be talking about um, applications for correlational strategies. So this is going along with learning objective 4 for the chapter. And again, it's basically talking about how you can use correlations for three different purposes: for predictions, for measuring the reliability and validity of a measurement or a tool, and then for evaluating theories. And those are the three examples that we're going to discuss in this section. Um, Again, prediction, reliability and validity, and evaluating theories. So first, we are going to start with prediction. Um, so correlational studies and correlations in general, because they establish a relationship between two variables, that enables us to use that knowledge of the relationship and how one variable can influence the other um, to um, help predict or explain other variables. So, for example, um, there is an established good positive relationship between um, SAT scores in high school and college GPA. So that means a higher SAT score in high school um, means that it is likely that the college GPA for that student will be higher as well. And so, in other words, students who do well on the SAT in high school tend to do better in their college courses. And so, of course, that is not a perfect relationship. As we discussed in the last video, no relationship is perfect, especially when it comes to behavior. There's way too many other variables involved. But since there is an established um, positive relationship there, um, we can then predict, colleges use SAT scores to predict the success of the students in their institution. And so that's part of why, in case you've ever wondered why SAT scores are part of your college application process, that is why. Because the colleges, the admissions people know that if that you can use those high school SAT scores to predict um, the likely performance, GPA of a student in their college. And so that's just one example. Um, so in situations like that, like what we just talked about, there is a pretty clear um, prediction relationship in the sense that, as we talk about down here, the two variables, there's a predictor variable and a criterion variable a lot of times. Um, and what we mean by that is the variable that's doing the predicting and then the variable that we're actually, explaining or um, that's being predicted. And so here in that example we talked about, high school SAT scores would be our predictor variable, and colleges are using that to predict the criterion variable, which is the college GPA or the performance in the college classes. Um, Now, you could also do it the other way around. You could, if for some reason you wanted to know um, what their high school SAT scores likely were, you could look at their college GPAs and use that to predict. Um, but obviously, that doesn't seem quite as useful, right? Um, so, in most cases, there's a predictor variable and a criterion variable. Sometimes there's not. So, it may just be whatever variable is more available. And so the example your book uses is parent and child IQ scores. There is um, a good, positive, fairly um, moderate to strong relationship between parent IQ scores and child IQ scores, meaning that if a parent's IQ score is higher or lower than their child's IQ score is likely to be the same, or similar, either high or low. And so, um, if you have access to, like, if you are working, going into the schools, or have access to intelligence tests that were administered to students in schools, that's more readily available. So that would be your predictor variable in that case, um, if you wanted to call it that. And the adults' IQ scores would be what you are predicting. But you could see where you could do it the other way around. If you were in more of an industrial, organizational psychology field where you were going into the workplace, for adults and evaluating the employees on something, and you had access to intelligent tests from the adults, then that would be the readily available variable, and you could use that to predict the child's IQ score then, because that would be the variable that you didn't have access to. And so again, it just depends on the situation. Um, Obviously, in some situations, like the first example we talked about, or in this next example I'm going to share, there is a clear cut predictor and criterion variable. For example, similar to the college SAT thing we just talked about, um, grad schools use those GRE scores to predict performance in grad school. Again, similar situation. So the GRE would be the predictor variable, the GRE scores, and the criterion variable would be your performance in graduate school. So how do we do this predicting? Well, there is oftentimes it is called regression. It is finding an equation that is like the best fit, the line of best fit, the best fit equation. If you have an algebra background, that it's the best fitting equation that produces the most accurate prediction of that criterion variable, which is usually called y, for each value of x, which is the predictor variable. Um, and so, um, usually using this regression equation, the example they gave you in your book was a study where they found that higher positive affect scores, which basically means lower depression scores, um, they found that it predicted better problem solving skills for older adults. So they found an equation that most accurately predicted the problem solving scores for each of the affect or low depression scores. And by doing that, they were able to predict what the problem solving ability would be based on the predictor variable of their depression or affect scores. Um, so, um, there's also scenarios where the criterion variable may be undefined. And so, and you're just wanting to find out more information about it, um, or just about the relationship between an unknown, more undefined criterion variable and the predictor variable. An example of that is um, researchers are constantly looking for environmental and genetic factors that are involved in the risk of Alzheimer's. And, Alzheimer's is a very complex disease. And so the predictor variable is, risk factors for Alzheimer's, right? But we want to predict, um, or we want to, see what we can predict from that. But we don't really know for sure what all the environmental and genetic factors are, and so it's not clearly defined. It's not fleshed out, and so you can still do these studies and do these correlational studies and use prediction, even if both variables aren't completely defined. And so that's what your book wanted to make sure that you guys knew. So our other two ways that we can apply the correlational research strategy, our other two applications are the reliability and validity of a measurement or tool and evaluating theories. So for reliability and validity, remember from chapter 3, if you need to review what reliability and validity are, go back to chapter 3. But remember, reliability is the consistency or stability of a measurement or tool, and the validity is how accurate it is, how true it is, how much it's actually measuring what it says it's measuring. And so the reliability and validity of a measurement or tool is often established by using correlations. And so the two examples that your book gives is test-retest reliability. So if you remember from chapter 3, you would administer a test to, if you're trying to test the reliability of this test or this instrument, you would administer it, and then later you would administer it again, and you would compare the scores. And if the person or the participants scored similarly, if there was a high correlation between the results on both times the test is administered, then you would be able to say with confidence that it is a reliable test because they are getting the same scores both times. Obviously, if they didn't get the same scores, but it's the same test, then something is clearly not reliable about that test. And so having that high correlation coefficient would help establish that. For validity, the example they give is concurrent validity, which is the most common when a correlation is used, because what they are doing is they are taking a established test that has been shown to be valid and comparing it with a newer test to see if it's valid. And if they have a high correlation between each other, between the results on both, then you can say, well, if this one's established as valid and this one highly correlates with this established valid test, then we can assume that this new test is also valid. The example they gave in your book is about an Alzheimer's screening tool, and it was a 7-minute one, and it was a condensed version, but it was a newer version. They wanted to see how valid it was at screening for Alzheimer's, and so they compared the results of it with the results of established Alzheimer's screening tools. And if it was a high correlation, then you would say that yes, it is a valid tool. Now, this second point down here is talking about the evaluating theories. So there are lots of theoretical questions out there that correlations can be used to address, especially if, again, you're just looking to describe a relationship that may or may not exist. And so a common example is correlational studies of the IQs of identical twins, because a lot of people want to know if IQ or intelligence is nature or nurture. Is it genetic, or is it largely dependent upon your environment? And if you are curious about that, you can study identical twins who are separated at birth, because genetically they have exactly the same material, right? Same genetics, but they are raised in different environments because they were separated at birth. So we can compare their IQ scores and see if there's correlations there. If there are correlations between their IQ scores, then that would suggest that IQ is largely genetic. If there's not a high correlation there, then that would tend to suggest that IQ is mostly environmental. And your book explains there's actually kind of mixed results there, but there is a lot of studies that do suggest that IQ is more genetic than anything else, but environment definitely does play a factor as well. But so that is one example of how you can answer a theoretical question like, is intelligence more nature or nurture? And you can use a correlation to answer that question. All right, so let's go to our learning check. Dr. Jones hopes to demonstrate that children who eat more nutritious breakfasts tend to have more academic success. So if they do find that relationship, then which would be the predictor and which would be the criterion is what this is asking. So if the more nutritious breakfast is predicting the academic success, then the predictor variable would be the breakfast, the nutrition level of the breakfast, and the criterion variable, what you are predicting, would be the level of success of, or their academic success. So that would be this first answer here. Again, because the breakfast is what is predicting the level of academic success. Which research design is commonly used to establish the reliability or validity of a measurement procedure or tool? And you probably could have guessed this just because that's what the chapter is about, but obviously it's correlational design. But we literally just talked about that in the last slide. So again, correlational studies are used to establish reliability and validity of measurement procedures or tools a lot of times. A researcher uses a correlation to demonstrate that a new 5-minute test for intelligence produces scores that are strongly related to scores from traditional or established IQ tests. What is the researcher attempting to demonstrate about the new 5-minute test? And this is exactly what we were just talking about in the last slide as well. That is a type of concurrent validity. So they are trying to establish the validity of the 5-minute test by saying that it highly correlates with traditional or established IQ tests that have already been shown to be valid. So hopefully that helps you guys with that. And I will attempt to record 12.4.